This is Tim Hegarty with Virtual Training Company, talking about C++ fundamentals. We want to talk about virtual functions and overloading. These are functions that are defined within a class. They are class functions, methods of the class, and their purpose for being is kind of a placeholder in a base class. They assume that they will be replaced in a derived class. So when we make a derived class and derive it from a base class, a virtual function can be overridden. It can be overloaded or changed. A non-virtual function, which is what we've worked with so far through our fundamentals tutorial, and I'm sure you've seen them in other places without the virtual keyword, those are not overridden. They are linked in at compile time, and those functions and their addresses are linked together hard, and that's called static linking. And whenever a class is derived from a base class and you call a function that's in the base class, the one from the base will be executed. Well, we want to be able to run the function that is in the derived class, not in the base class. So in the base class, we have to define our functions as virtual. That will allow them to be linked at runtime. So the derived classes can provide their own functionality. That's called dynamic linking. The way we do this is the compiler creates a vtable, a virtual table, as part of the class. The vtable is then populated at runtime with the addresses of the overriding functions. Let's take a look at a piece of code and try to put this together a little bit. Here we have an example. We have a polygon, and this is our base class of polygon. And it has a width and a height that are protected, but it has a set values, and that's a standard method, a public method, and it'll take two integers and set the width and the height. Okay, we don't need to change that in derived classes. That's fine through any polygon. But the area of different kinds of polygons will be computed differently. So we make that a virtual. It'll still return an int all the time, but it's going to be a virtual function. And here we just return 0. So a base polygon would return nothing for the area. It won't do any work. But when we derive a rectangle, here's a class rectangle derived from the public base, or from the base C polygon, and we use the public access specifier so that everything that's in the polygon will pass through with the same level of access security on it. And then we make new public items, members in the C rectangle, and here we're making a new area. So here we are overloading or overriding this virtual area. The area of a rectangle is the width times the height that we will return. So if we make a rectangle and call the dot area, we know how to compute that. If we do a triangle, that needs a different kind of area, and that's going to do a width times height over 2. Okay, that's a different overridden area. And again, C triangle is derived from polygon, but we can change area because area is a virtual. So you got to remember that keyword virtual if you're going to be overriding these methods in your derived classes. That's what a virtual method and overriding of a virtual method is all about.